Okay guys, welcome to the KiCad tutorial, but this time it's going to be more in depth, covering how to make a schematic, how to turn that into a PCB, and how to trace all the lines on that PCB. So first, once you open up KiCad, we should go to File and New Project. I've already named my project PowerBoard Demo. I'm going to be teaching you guys how to make the PowerBoard that we will give to you guys. So first things first, let's go to our preferences and let's manage the symbol and footprint libraries. So just like how you guys are making your schematic, we want to make sure all of our symbols and footprints are in the right place. And so far you've only worked with symbols, but now we are going to involve with footprints. So I am going to stay in my project specific library to make everything more consolidated. I'm going to go to this folder here. I am going to go to my libraries. So we will provide these libraries to you at a later date for your final project. But basically, I'm just going to go through this list and then import everything that I have. So let's import the schematic library. And then now let's go one more step up and then go to the second one. So now once we have all of our 8 symbols that we've selected, we can go press OK. And then we're going to go back and we're going to go manage footprint libraries. And then you're not going to have these, but since I already done it, but basically what you're going to do is press this little file folder, go back to where you got the libraries, and all you need to do is click the folder that these parts are in. So all you need to do is click this folder. Nothing's highlighted, that's fine, you just press open. And you can see that it already exists, but for you, you're going to be adding it new. And make sure you're going to the project specific libraries here. Then let's go back and click OK. Now we will go to the schematic editor. So let's go ahead and reference our sheet here and start placing our components. Let's start with the LDL1117S50R. This is going to be your 5-volt LDO. So we can go place symbols, and I already have it searched up here, and remember we're doing the 50R. And if you've imported your footprint libraries correctly, you should see this footprint show up here. Same thing as the 33R, we use both of these components. So let's place this one here, and then let's go ahead and place the 3.3 volt LDO, which is named 33R. Cool beans. So once we got these placed, go ahead and zoom in, make sure everything looks good. Let's go look at our schematic again. Now we need this battery connector, we need this pin, we need this LED diode, we need this resistor, we need all of these things. So let's start with the battery pin here. So we're going to go back and look for B2B. So place symbols, B2B, and let's see. Oh, I have a duplicate here, but since you've never imported these before, only one should show up, and it should show up here. But just make sure you have the footprint associated with it too. So let's place it here, and I'm going to press R for rotate so I can make it go towards the right. And I'm going to move to the left here, give it some room, and there we go. Now we need to do the PC712A. Let's put that in there. Place symbols, PC712A. Also hide that, and then make sure that there's a symbol associated here. Then let's rotate R, R, R. Cool. There we go. Now we're missing a diode. It's the 1N5820 diode. 1N5820. And then you won't have this in your imported libraries, but KiCad is really nice that it's defaulted that it will have the diode and the associated footprint for you. So just use the KiCad default for this diode, and then let's turn it around. I think it goes this way. Let's double check that. Yep, it goes that way. And then we need a resistor and another diode. Oh, okay, the diode actually goes the other way. So we can click on that component and then press R, and then we can drag it back up here. Let's look at this resistor, RC1206. Okay, let's see if that's existing here. RC1206. Okay, cool. So this resistor exists in the KiCad libraries already. So we can just grab and use it. So again, I'm going to rotate it and then connect those that end there. Come back and look for other things I need to do. I need to place a LTST C171. That is a LED. Just making sure I have this right. LTST. Okay. LTST. And then C171 KGKT. Great. Perfect. And that is going to go this way towards the ground. And then we should have some capacitors. These look like different capacitors. So let's look. C0805, C475. Okay, let's place that one. Go back and look at it. 0805, and it's gonna be C475. C475, and here it is. This is also existing in KiCad already, so we can just use the default symbol here. And I believe we have two of the exact same ones, here and here. So let's place one over here and one over here. Oh, I think you have to copy that component. Yep, there we go. And then rotate it again. And then make sure that it's 2, 1, 1, 2 in that configuration. Actually, I think for surface mounts, capacitors don't really have a direction, so you can ignore what direction we put them in. It doesn't really matter. Now let's find the C0805 C10 58MA RA CTU capacitor. Let's go to place symbols. Let's type that in. C080 5C 5C1. It's gonna be 5C105 05. Okay. Now let's place two of these. So you're gonna click it again to pull it up, or just press copy, and then you can press paste. So those are our resistors. Capacitors, and then we will need a battery connection pin, and I also believe that that is a default KiCad symbol, so let's go look for that. So KiCad makes it really nice for us that we don't have to import absolutely everything. Let's search for con 01. I believe it's times 04. Nice, that's perfect. And it does not have a footprint, so we might have to import its own footprint. And it's the pin here. So, and then I believe we rotate it. Yep, let's rotate that a little bit. Now in your actual schematic, you don't have to make sure everything rotates. As long as they're connected correctly, that is perfectly fine. So now let's start. So we know that for the batteries, we have positive on the 1 pin and ground on the 2. So let's add the ground there. We're gonna go to place power symbols. We're gonna look for ground. So just G and D. And then I prefer using this power symbol. It's just the cleanest one. I mean, you can look through all the other ones. I just really like this one specifically. So let's go here. Let's ground this one. Let's make sure that we're also grounding everything else that we need. So that's gonna be down here by this LED. And then I believe that ground needs to go here and here. So let's grab this ground, copy it. So just Control C or Command C if you're using a Mac, and then paste it here, and then paste it here. So we got 1, 2, 3, 4 grounds, and ground on the pin number 4 of our J3 connector. J3? Yeah, on our 4th pin here. Okay, looks like I actually did this backwards. Let's rotate it. So RR, and then that's That's good. And then let's do paste. So when I say R, you click the symbol and press R for rotate. And then let's connect the middle pin of this connector here with the positive line on our battery. So that is going to be place wires. Make sure you're clicking on the node. So if I zoom in here, you will see what I'm talking about. Like if I accidentally click over here, that's not going to connect. Make sure everything has this cross in the middle here. And you see how that circle went away once I connected it? Let me demonstrate that again. So you see there's a circle here. And once I connect that pin, oh, oops. I'm going to trace this way so I don't short these two pins. So I'm going to go over here and then click here. And you can see those circles went away. That means they are properly connected. Now, the next step is tracing SLV to the end of this diode. So let's do SLV. And then let's make sure not to short our lines here. Now, a way to distinguish, these two lines are actually not connected because there is not a circle in the middle. So if you want lines to connect to each other, you will have to click on the line, and you can see that there is a circle there. That is what's called a node. But we know that we shouldn't short these pins because of our schematic design that we're referencing. Now, realistically, this thing is basically a connector. So the battery current, the battery power goes through this line and goes through this line. Now, here is a physical device that you will see on your power boards. Once you unplug it, then the current flows through this arrow. If you plug it back in, there's no connection between the middle pin here and the left pin here. So that's how that physical device works. So we don't want these two pins shorted down here because then it's pointless having a switch on this end. And the next thing we need to do is from the diode, which is our battery power line. We will name it battery later. So that is net labels. We will talk about that in a little bit here. And then we will go to the 5-volt LDO and the 3-volt LDO. So the same thing, we go to place, wires, go to the right side of this diode, go up here, click once to kind of make sure that it stays on that point, and then click to 3. And then this is really convenient. I've placed the capacitor in the right place, so that's a node formed there, and I just need to connect that node with the ground. So let's go ahead and do that. Make sure that node symbol pops up, and then let's do the other side of these capacitors. So this end will go to ground, this end will go to V out. Same thing over here. This end, this end goes to here. That's a node there. That means those two wires are connected. This end goes to here. Great, those ends are connected. Let's ground the other side of this capacitor. Make it look a little prettier. Okay, there we go. Sorry, that did not look pretty. Let me redo that. There we go. Then the other side needs to go to the capacitor here on our 3.3 volt line for the V out. So connect this, and then connect. Sorry, I'm just making sure I do everything right. Connect this end, and then connect this end here. So now let's get the net labels out of the way. So we need a bat, 5 volt, and 3.3. So let's go over here using the net labels tool. You can also just press L as a shortcut. Bat. And then, okay, there we go. And then you can drag this out. So you see that green line that verifies that you're actually connected there. And then we need the net symbol for bat over here. Bat stands for battery. So this is just our battery line. Boom, right there. And that should be fine. Let's do another net symbol on our 5 volt line. 5 volt. Let's make that small case. And it's going to be the V out on this 5 volt LDO here. Anywhere on that line will be good. And I believe that's the second one. Yep, bat goes over here. So and then it's going to be 5 volts. And then you're going to click here, and then you can drag this. Oops. Click on the 5 volt letter and drag this over here. Next thing we need is a 3.3 volt. So 3.3 volt. Yep. And then click here, then drag. Click and then drag. Same thing on the 3.3 volt LDO here. Make sure you're naming the net labels all right, or else it's not gonna work. Make sure you're saving this frequently. Once we've saved this, we can go ahead and create a PCB. So we are going to go to File, Save. So before we move on to the PCB, you might remember that we did not have a footprint for our battery connector here. And if you remember that we had footprints for all of these other symbols, so when we go to place symbol, you see our connector pin here doesn't have a footprint. There's no default footprint. So we can actually assign it here before we place. So that's actually the better way to do it, but I wanted to show you guys how to correct a mistake you've already made. So now we know that this doesn't have a footprint. And now if we go to Tools and Assign Footprints, we can see that everything has a footprint assigned except for the J3 connector pin, which is this. So let's go back to our Assign Footprints tool, wherever that is. And then let's click on the connector pin header 2.54 millimeter. We're using this one here. So I'm just going to search for it. I've already put in the search bar, and then I know it is the 1x04, and I know it's the vertical one, and I know that it is not the SMD, which stands for surface mount. So I'm just going to double click and make sure that this pops up here as you've intended. Then you're going to click Apply, Save Schematic, and Continue. After you've done that, you can press OK. Now we are going to save our schematic. Well, I guess I already did that, so we can exit out of the schematic editor. Then we are going to do the PCB editor. Now we are going to go to Tools, Update PCB from Schematic. Now, if we've done all the parts, all the steps correctly up until this point, you should see total warnings 0 and errors 0, because everything, diode 1, capacitor 4, capacitor 1, diode 2, all has its own associated footprint. So now we can press Update PCB, close, and then we can place all the clumped together footprints over here. Now, what you can do is click one of these and just move it around. So with our power board, we've elected to make something that's like a square. I'm gonna make it a little bit more simple, but you guys can feel free to do whatever shape you want. So let's kind of mimic what the setup Felix has made for us here. So we are going to have this J2 connector in the middle next to the J1 connector. So J2 connector in the middle with a little bit of spacing for all the things here. Make sure that these LDOs can easily fit here. And when something pops up as red, that means they're interfering with each other. So make sure that doesn't happen. I am gonna select all of these, move them somewhere else for now, and then place my diode down here. I guess Felix had it more, so over here. And then we will put some capacitors where they should be, and resistors. So you notice these capacitors, they're really close to the actual LDOs that they're using, so we're going to do the same thing. So you can see the traces of these, I guess you call them cyan lines of where they should be. So this one looks like it needs to be over here. So let's press rotate. Oh, how do I rotate this? Oh, there, we can use these keys up here. So Shift plus R. And let's look. Okay, that looks like we're doing a crisscross here. That's not great. So let's do it twice. So now we can see that there is a cyan line going from ground to ground, cyan line going from 3.13 to 3.3 volts. Great. Okay, hold on. That doesn't make too much sense. Does it? Oh, okay, actually it does, because these two should be shorted with each other. Okay, we're going to do the same for all of our other capacitors. That is a diode. We will touch that later. So let's zoom in here. This one looks like it belongs here on the left side. So let's do Shift R, Shift R, Shift R. And then let's move everything just a little bit so we have some space to work with. This one, let's rotate this. And it's, yeah, that looks. Okay, that looks good there. And I just need to make sure, because it looks like the ground is swapped in this case. I'm just going to go back to our schematic to make sure we have what exactly matches this drawing here. So we have 2 going to power. Let's go back to our schematic. Oh, I made a mistake, guys. So here is another interesting tip. How do I fix something that was connected wrong? So I've actually accidentally switched these terminals. Now what you're going to do is you're just going to do the corrections as needed. So we're going to delete this trace. And let's actually delete this ground too, because that is wrong. Mirror vertically. So now that we have that, 1 should go to the middle line there. Okay, so 1, trace it back, and trace it back there. Then now we're going to place our ground symbol again. So that is how you revert a change that you've made an honest mistake, right? So now, what happens to our PCB, right? You may ask. So what's actually going to happen is if you go into your PCB editor again, and then you go to, okay, let's remember the orientation here, and then let's go to Tools and Update PCB, and update and close. You can see, hey, now those lines are reverted while nothing else has changed because we didn't change anything else on the schematic. So that's how you can go back and fix one of your silly mistakes that you might make. Like everyone makes silly mistakes. So let's go ahead and rotate this. That looks much better. Make this a little closer. Then we are going to bring the rest of the capacitors over. This one looks like a capacitor that goes here. Oops. Let's go Shift R, Shift R, Shift R. Okay. Oh, actually, that is a battery capacitor, right? Let's see. So it looks like he actually just has all the capacitors here. Okay, we'll follow that same convention. Yeah, up there is fine. And then we'll pull this capacitor over here. And then we can see that that looks like a good spot. Perfect. Okay, so we have a resistor here and an LED. Let's just put that somewhere that is out of the way. Okay, great. Now let's make sure to save our schematic. Okay, so now we have everything kind of laid out right. We're gonna make the actual size of the PCB. So we are gonna go on the right here, select the layers, make sure you're on edge cuts. Then you guys can make a rectangular shaped, or in your actual project you can make it whatever shape you guys want, right? But for the sake of simplicity, we will make it rectangular shaped. So I'm gonna click once, and then I'm gonna click one more time, and then I'm gonna make this just a tiny bigger. And then let's look at our PCB again. Looks like, oops, we need some mounting holes. So mounting holes are quite simple. We can just go to place footprints, and then if we search for mounting holes, there are all sorts of mounting holes that KiCad's own internal libraries has. So there's all sorts here. There's these ones. I am gonna use the 5mm pad top and bottom, but in your actual project, if you wanted to use mounting holes, you can choose and experiment with whatever you would want. So top and bottom, that means it's through and through. We will show that in the 3D model actually. So let's do a 5mm pad, one top and bottom, one top only, and one via, just to show you guys what that looks like. Okay, so let's do this. Place this here. Oh, that is that is bigger than I thought. Okay, we're gonna make our PCB a little bigger just for the sake of it, and then we are going to place a mounting, and then we're gonna do another 5mm one, but this time we will do top and bottom, and then just keep placing. And this is just for demonstration to show you guys what this looks like. Top only, and then we'll have to get one that's a via. I'm gonna move this over here. How do I move this? There we go. Let's move this over here, and then we will place a via. Mounting hole with via. Now, there's a really cool thing here in KiCad. Let's save this real quick, and then we can view it in 3D. Now, we can rotate it using our left mouse button, and you can see kind of what those pads look like. So remember, this is one, I think that one's the top only, so it doesn't have the same protective copper layer on the bottom. The vias, they have through holes here, so those are you don't ever need to use vias with pads. However, when you are tracing components, you may need to use vias. And then it looks like the top and bottom and the generic one looks all the same. So let's close out of our 3D viewer, and then let's delete the top only one. Select all, select delete, and then select all, and then delete, and then let's place some more pads here. So we have recently used. Let's do a top bottom right here, and then I'm also going to delete this one just so I'm very consistent across everything. So I have 4 of the exact same ones. Cool. So now we have that. Let me expand my PCB just a little bit because you see that those letters, we want those letters to be printed so it doesn't cut off. So now if we go to our 3D models, well, you can see that there are some edges that we may actually we can shorten that. Yes, that's fine. So I think the yellow ones, it's actually the yellow text will actually be printed in your PCB. So those are called silks. They're silks. That's just how they're referred to. Then now we can move on to tracing this board. So remember previously we were working the edge cuts layer. Let's go back to the FCU layer. Right, so if we toggle that, we can see everything red is on that layer, so we want to trace from that layer. And then we want to click on the root single track. So let's click on that tool. Then now we can start routing. Now you already have these thin lines to kind of guide you on where to route things. So that makes it really helpful. So let's first start with our battery connector. So this ground, and you can make it whatever shape you liked. So I like to go out first, and then go straight this way. And then what I'm going to do, since this is a battery line, I'm going to adjust the track width because we want a thicker battery line because that's where all of our current is flowing through. So let's select this, press shift, and select this whole entire line, and then double click to edit the properties. Let's do 0.4 millimeters. Press OK. Okay, now that has become thicker, and it looks like I didn't get both of these. So let me try that again. Okay, so now both of these are selected. So right click to do properties is the same thing as double clicking. So now those are wider traces. Actually, those don't look wide enough for me. So I will just make them even wider, we will give you guys a quick reference guide of what all of your properties should look like for your final project. But just familiarize yourself with this. So I guess I'm practicing right now. So that is our ground, and then looks like let's do another trace. Looks like this R1 goes to this D2, and then I like to route a little further away from the components, just in case if you accidentally break something, it's easier to fix. So kind of like what I'm talking about here. So you see that's like away, going away, not touching that component. And then we will trace from, make sure you're clicking this routing tool every single time. Then now you see that you cannot overlap the same layer because these are both red wires. These are going to be on the same layer. So now we're going to have to go around. And then I'm also going to make that a little thicker because it's the battery connection. So I'm going to select this whole entire line. And then right click properties and make that 0.6. So now let's do another trace from here to here. Now, if you guys remember, this is actually one of our switches. So the battery power goes to this switch, and if we disconnect the switch, then battery power will flow from this pin to this pin. So that means battery power is also flowing through this line. So let's make that line thicker too. And this is generally a good practice to make your power lines thicker, because there's just more current and voltage running through them. And since this is a power board, we want to be really careful to make everything work. So, and then you see here, that's a little close for comfort. So I'm just going to click, and then I can drag to change how those traces are. So then this is a diode. A diode allows one direction current flow. So the current will only flow this way. Only flow this way. So now, let's trace some more. So it looks like we have to route around again. And in your board, if you're tired of routing around, you can right click and then you can place via. So vias allow you to route to the other side of the board. So we're doing basically 2 layers PCBs. So there's going to be a blue and a red layer. So now this blue layer is on the other side of your board. So now we are on the blue side. But be really careful when you guys are doing vias and routing via the other side, because now you see I can't actually connect to this component. That is because this component right here is a surface mount component. There is nothing to connect to on the other side. So to connect it back, you see, I click and nothing happens. So I actually need to place another via. So be strategic about where you guys do vias, because in this case, it's better to have a via on my power line and no vias on here because it's going to a surface mount component. On through-hole components, since the hole goes through the top layer and the bottom layer of your PCB, you can do the red layer or the blue layer for tracing, so the top layer or the bottom layer for tracing, and they will both accept it. So let me keep tracing from here. Oh, and since I already placed the via here, let me go to the blue layer, and then now I can keep tracing. You see how if I go to the blue layer, only some of the components turn blue? Like these pads do not turn blue, but these through holes all turn blue. So that means you can route to them when you're in the blue layer. I hope that makes sense for you guys. So now let's right click and place another via. And then now, when you place a via, it automatically routes you to the other layer. So now you can see my wire is automatically red. And then I can place that right there. And now I know this is also a battery line, so guess what I'm doing? I am gonna make all of these lines thicker. need to zoom in a little bit here. It's not letting me click this. There we go. So properties, and then track width is 0.6. And then you can see that I've also accidentally selected the via. You can also change the via's diameters too. We don't really mess with that, but I guess you could mess with that if you'd like. But yeah, basically what the via is, if I look at the 3D view, the via itself, oh, you see, we can see those holes. So if you use your middle mouse button, you can move around, and then use your left mouse button to rotate in the 3D viewer. So those are my vias. So the via is basically a hole that lets electricity flow from the top side to the bottom side. So make sure you guys don't solder those holes in. That would cause a short if you have a, maybe like a ground polygon layer. So now let's go back to our red layer, so the top layer, and let's keep tracing. So let's go from here. Oh, need to press the trace button. Go from here, and then looks like we can just route around over this way. And then I really don't like 90-degree angles, so make sure you're trying to avoid that whenever possible. And oh, it looks like I think since I was doing so many 0.6 millimeter traces, it automatically did that. Okay. Oh, and there's predefined sizes that you can do, but we don't have any so far. So let's keep looking here. R1, D2, so that's battery, so where does that go to? Oh, that is our LED, I believe. Let me double check my schematic. So anytime when you're not sure, you can go check your schematic. So just as a sanity check, we know we have battery power going to one side of the resistor, and the other side of the resistor goes to our LED, and then goes to ground. So let's double check that. So we have battery power going to one side of the resistor, and then from that resistor, it goes to our diode, which is our LED, and then it goes to ground. Okay, that's just a sanity check. And then let me keep routing. So we need to have a lot of grounds that, oh, see, I don't like these things getting too close, so I'm going to go a little bit this way, and then go straight, and then go back down. There we go. Then now let's actually start working through all the grounds and just connect all the grounds. So in your actual PCB, I think we are going to ask you guys to do a ground pour, but since this is such a small component, there is no ground pour needed. So a ground pour is basically when you pour in an entire layer as ground, and then you just connect certain holes with that layer. Let's see, make sure all the grounds are connected. I'm going to route this actually this way. Oh yeah, so it looks like it remembers. It's kind of smart that it thinks I want all the grounds to be of the same trace size. See, are there any more grounds that I haven't connected? Looks like there isn't. Okay, cool. Now let's route battery power, and I'm gonna start from here because now if you start from somewhere that has a thick trace, it's gonna remember that. So I need to go over here, and let's. Oh, so that's battery power. Let's actually start. Yeah, we can go over here. So I'm gonna go down a tiny bit, and then you can route over your blue traces because these are not on the same layer. Perfect. And then let's route. Okay. Looks like we might have to do a via here. So let's right-click, Properties, Place Via, and then I'm going to go straight up, and then I'm going to place another via here, and then I think I lost my trace there, so let's go back to the blue layer and then keep on tracing. Oh, no, it's the red layer because now we're on red. Then trace that to that. battery. Perfect. And then now we can just trace here. And you see it once after I'm connecting things, these tiny cyan lines start disappearing. That means you're doing the right thing. If after you've placed some traces and those cyan lines don't disappear, you might be on the wrong layer, or you're not actually connecting it to your through holes. So it looks like we need to 5 volt to 5 volt to 5 volt to 5 volt. So we need to connect all of these together. So let's place a trace, and then we might have to be smart about how we do this. And since we're also on 5 volt, let's make our 5 volt line also 0.6 millimeters thick. So I am gonna trace this first, place a via here, and then trace across here, and then place a via here, and then, oh, okay, I messed up just a little bit, so I'm gonna place a via. So if you just need a separate via when you're not tracing, you can just use the place a via here, and then come back to red, and then now you see that via is going to be both blue and red because it has 2 separate layers. So place that. So that's connected. So let's select these wires. And then we want to make this wire thick. So right click, properties, and then let's do 0.6, and then we won't touch the via properties. And then now we're going to stay on the red or the top layer. 5 volt, go directly across, and then 5 volt here, and that looks like our 5 volt LDO is finished. And now we need to go to our 3.3 volt LDO. So same thing as before. This is a power rail or power line. So let's look at the properties, and let's change that to 0.6 for width, and then let's keep tracing. And for simplicity, I'm just gonna go trace around because I don't want to place a via and then another via to come. Actually, if I place a via here, since this is a through hole, I do not need a second via to come back to the red layer. Let me just demonstrate that. So let's place a via right here. So now we can directly connect through, because it's like, imagine the red is your overground bus lines and the blue is your underground subway. So you can route blue under red with no problems. So now just looking around for a sanity check, making sure that there is nothing else not connected. Let's press save, and let's view our 3D viewer. Would you look at that? And yep, that is good. And then for labeling, you guys can go to text, and then say we want to label something as positive just to remind ourselves, and see that's a red positive there. And then I know that this side of the JSD connector is positive, so I'm just going to place that there. And then let's go to our 3D viewer. Now you can see the little plus sign. Okay, now basically to add a logo to your footprint or any type of image, you will go to well, let's save our changes first. You will go to the image converter here. So I found a UFM logo, and you're just gonna basically go to load source image and load a JPEG, or I think they take PNGs. And then you can see what it looks like in black and white or the grayscale. So I am going to adjust the size a little bit because 120 millimeters is way too big. If you remember, our traces were like 0.6 millimeters. So I'm just gonna make this 4 millimeters, and then if you press lock height and weight width ratio, it's automatically going to do that. And I would want it to be a silk screen. A silk screen are those yellow texts that you see in the PCB. So if we go to our 3D viewer, so you see all these yellow texts. Actually, they're going to be white texts, and they look yellow in our footprint PCB editor, but I like using that, but you can use other things as well. So I will just say export the file. I am going to put downloads and then save it there as logo. Now KiCad likes to do a weird thing where it really likes to have your footprints inside of a folder, so I'm just going to create a folder and then put my footprint in there. There it is. logo. Okay, and then I'm just going to move this in there. That makes things a lot more simple when you go into KiCad, because then we will go to Preferences, Manage Footprint Libraries, and we've done this before, right, for all the footprints, and you remember that you just need to select the folder. So we're going to go ahead and do that, and then now I can place a footprint, and then if I search for logo, there it is. Oh, that looks a little messed up. I don't know what happened there. Okay, that might be just something with this image that, oh, I can delete that. Oh, perfect. Okay, cool. Now we have the UFM logos on our PCB. Now let's go see our 3D viewer. Now you can see the UFM logos in white. And if you like them in dark green, kind of same with the traces, you can use the FCU layer when you export this here. And then let's say if we export it to mask, it's going to look a bit different, right? So we're going to go ahead and do that. Then got to remember to go to Preferences and then Manage Footprint Libraries and add that library. Press OK. Go to place footprints, and it's going to be logo 3 this time. And we can delete this. And now the color looks even more different. And you can see now it is a red kind of color-ish because we've placed it on the mask. So it's a different material. And so basically, you're finished with your PCB at this point. Before we do that, however, everyone should run a electrical rules check. So, design rules check. So we'll go to Inspect and go to Design Rules Check. And then some warnings are fine, like text thickness out of range. Those things are, silk screen clipped by solder mask. This is also fine. That just means your letter covers the solder mask, but since they cut it, it doesn't matter anyways. But it looks like there is an unconnected item. A PAT 2 on battery of C4. I see. Okay. There it is. Okay, so it's a very good idea to run the electrical rules check to catch any mistakes that you've made. So don't be silly like me. So let's go ahead and connect that, and we're on the top layer here, so we should just be able to connect this straight to the via. We're just gonna go from this side actually. Perfect. Now we're gonna save, and then let's run the rules check again. Run DRC. Warning, silk screen, that's fine. Texts, that's fine. Text height, that's fine. Unconnected item, okay, ignored. Footprint has no courtyard. Footprint doesn't match symbols. For documents, okay. Cool, so that should be fine. Just make sure you guys have no critical errors there. And make sure you guys have no routing errors and everything's connected. And see, it actually points to where those warnings are, and you can see these are just text warnings. So this J2, we can just move it a tiny bit. This C1, I think it's basically saying it's too close, but that's okay. C3 here saying that this is too close, so let's move it a little bit. These are just mostly for aesthetic purposes. But yeah, make sure you guys submit a PDF of this and also a PDF of your schematic, and I believe we would also need a PDF that you've passed the design rules. So you can actually save this design rules check as a document, but I think a screenshot of this, making sure that you guys all have warnings and no unconnected items.